Hey folks, we have another lesson today, a math lesson. This time we're going to be finding limits algebraically. Okay, so now we're not given a graph anymore. We're not given a table. We're just given some expressions. All right, so we're going to follow the following steps. We're going to plug in the value of x. If we get an answer, then we're done, and we're going to smile about that. Okay? That'll rarely happen, right? If we get 0 over 0, then we'll try one of the following. We'll factor, rationalize, simplify a complex fraction, or find the left and right-hand limits. If none of these methods work, then we'll estimate it numerically by going to the left a little bit and then going to the right a little bit of the point of interest. So in this case, we're just going to substitute in a 3. That'll give us 9 plus 3 plus 6 over 6. 18 over 6, it looks like. And that gives us 3. Since we get a number, we are done and we are happy about that. Now hopefully I did that correctly. I'm not going to go back and I guess I should go back and double check, but I'm pretty confident with that. Okay, here we put in 3. Get 9 minus 3 minus 6. So basically 9 minus 9 on top, 3 minus 3 on bottom. I'm getting this 0 over 0. And this is when we start our list. So we got 0 over 0. We're going to see if it'll factor. Well, that top one will factor. So make sure you write limit as x approaches 3, and then we'll write x minus 3 times x plus 2 on the top, and x minus 3 on the bottom. And you can see that the x minus 3's can cancel. Okay, in the next step, notice I do not write the limit anymore. I just write 3 plus 2. So basically what happens is I'm taking this 3 and I'm putting it right there into the x. So I'm doing 3 plus 2 and I'll get 5. And 5 is my final answer there. Okay. We'll look at a difference of cubes. This is a factoring technique that you won't have to memorize, but it's something that you can go back to and enjoy the beauty of it. So x to the third minus 8 will factor into x minus 2, and x minus 2 is on the bottom. Now we got to figure out what goes into that x to the third minus 8. Now you could do synthetic division there, but I think I have this memorized. Same, opposite, always positive. 2 squared, that'd be 4. Now what goes there in the middle? I kind of forget. Is it 2x or is it 4x? So let me see. X times that. That's right. It's these two put together. That's 2x. Now, I did pause the video there, and basically what I had to do was I had to look at the terms of this as 1x to the third, 0x squared, 0x, and negative 8. And basically I'm just going to do a little bit of synthetic division. 2 times 1 is 2, 0 plus 2 is 2, 2 times 2 is 4, 0 plus 4 is 4, 4 times 2 is 8. Those would cancel out. You get a 0 remainder. This would be the x squared, this would be the 2x, and this would be the 4. So anyway, that's how I got that. So we're going to cross out the common factors. And once I cross out, I'm also going to be putting in x equals 2 wherever I see an x. So I'm just going to call this 4 plus 4 plus 4, which is the same thing as 4 times 3, or 12. All right. Next problem. Uh-oh. You know what? I didn't even try putting in the 2 first. You should always try putting in the 2 first. If you did, you would get 0 over 0. Okay? So let's try putting in the 2 on this one. Well, I'll get 0 on top and the square root of 9, or 3, minus 3. So I'll get 0 over 0 again. So in this case, well, we've already learned about how to factor, a couple of examples. We're going to do rationalize. We're going to rationalize the denominator. So let's take a look at this. So you should know at this point that the difference of squares, if I had a minus b squared, it is the same thing as a plus b times a minus b. And you should also know if I have the square root of some number and I square it, then it would just give me that number itself. So that's all the prerequisite knowledge you need to rationalize this conjugate. I'm sorry, rationalize the denominator here. So anyway, let's take a look. The limit as x approaches 2 of x minus 2, let's put that on top, just like normal. And this bottom part is the square root of x plus 7 minus 3. Okay, so what you want to do is you want to make the denominator a perfect square. A difference of squares. So we'll call this the square root of x plus 7 plus 3. And we'll multiply this by the square root of x plus 7 plus 3. Now that red part there, if you divide that, that's just 1. Okay, so we're multiplying this fraction by 1, which is totally allowable. Okay, so you can do that. So all we're going to do now is distribute. So we're going to be simplifying just a little bit. So the limit as x approaches 2 of, you know what, let's not mess with the top yet. X minus 2 square root x plus 7 plus 3. Now the denominator, square root of x plus 7 times square root of x plus 7 is just x plus 7. Okay, now that rule comes from this. Whenever you square something that's under the square root, we're multiplying those two things together, right? And then the difference of squares says that we don't even have to FOIL here. We just memorize the formula. It's something squared. Okay? So if I'm doing the plus and the minus and I'm multiplying those together, this will be x plus 7 and then minus 9. Okay? So I squared that, the square root of x squared. The square root of x plus 7 squared is just x plus 7, and then 9. Okay, you can spend the time to FOIL that out, but what you'll find is that's what you're going to get. Okay, but now what I see is that this whole thing down in the denominator is exactly x minus 2. And x minus 2 will cancel out with x minus 2. All right? Now what we're going to do is just take that 2 and drop it in right there. So that gives me the square root of 9. I did some adding there, sorry. 2 plus 7 is 9. And then plus 3. That's 3 plus 3, and that's 6. Okay? All right, so I hope that was helpful. I'm going to pause the video. I'm going to have you pause the video and think about what you would do on that example there. Okay, so this example looks pretty similar to the last example. Let's plug in the negative 1. That'd be 3 minus square root of 9, so 3 over 0. So we're getting this 0 over 0 thing. We can't factor it. Definitely looks like a rationalized problem. But this time we're going to be rationalizing the numerator, and that happens often. So we got 3 minus, or we have 3 minus the square root of x plus 10 over x plus 1. and we need to multiply by 1. The way we're going to make 1 look is 3 plus the square root of x plus 10 and 3 plus the square root of x plus 10. All right. This is a difference of squares on top. So the difference of squares tells us that 3 times 3 is 9, so we'll write 9 minus, and then this one is going to be squared, so it's just 9 minus x plus 10. That's important. That's important to have this parentheses here. You don't want it to be 9 minus x plus 10, but it's 9 minus quantity of x plus 10. So anyway, on the bottom we have x plus 1 and 3 plus the square root of x plus 10. Now when you look at that, it doesn't look a lot like x plus 1, so let's distribute the negative symbol and see what we get. The limit as x approaches negative 1, 9 minus x minus 10. Okay. X plus 1, 3 plus square root x plus 10. All right, we're making a little bit of progress. 9 minus x minus 10. Well, I have a 9 and I have a minus 10. 9 minus 10 is negative 1. So that numerator, I want you to think of it as negative x minus 1. Now negative x minus 1, I could factor out a negative. Okay? And if I had more paper, maybe I'd show a little bit more work. But I took that negative out, and now I have x plus 1 exactly on top, and I have x plus 1 exactly on bottom. So I think that maybe your answer, if you were to try this on your own, you might have messed up a symbol. Okay? Just because there were a lot of symbols in here that you could have messed up on. This time we're going to drop in that negative 1 right where it belongs. And please remember that this is a fraction with a 1 on the top, a negative 1 on the top. There's a negative symbol there, and you have to have a placeholder 1 at the top. And now we're going to substitute in this negative 1 right here. So it looks like it's 3 plus 3, or 3 plus the square root of 9, right? So our final answer is negative 1 over 6. And I'm hoping that's right. Smiley face there. Great job, guys. That's kind of a long enough video. That's finding limits algebraically. I'll follow up with a few more examples in the next video.